Well, hello, Pre-ACE Math 3 students. Buckle your seatbelts because this is going to be a wild ride. I'm not the best with technology, and who knew that when we left for spring break that this was going to be the predicament that we were going to be in for the fourth quarter. So, let me get to where I need to go. That would help. All right, so you have a copy of 11.6 notes that we're going to do together. So the first thing I need you to do is you're going to need a calculator. So go ahead and pause the video and go get your calculator. Okay, all right, so this is section 11.6, and it refers to the same section in your textbook, and it is on probability and statistics. Oh, it's actually probability, because actually stats will be a little bit later. All right, so it's on probability. So this is probably not the easiest subject to teach remotely, but we're going to give it our best shot. All right, we're going to start off with what's called the fundamental counting principle. And this is probably one of the easiest probability problems to solve. What it says is that if decision M can be made M ways, and decision N can be made N ways, then the two decisions can be made M times N ways. So you just take the number of ways and multiply them together. So here we go. We have 4 examples. All right, our first example, oh, you know what, let me make this bigger. All right, here we go. All right, first example. The ice cream shop offers a choice of 3 cones, 15 flavors, and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping? All right, so we have the cone size, we have the flavor, and we have the topping. We have 3 options. So I think the easiest way to do this, since we have 3 options, is let's make 3 spots. All right, the first spot is going to be how many ways you can choose the cone size. Well, it says that there are 3 cone sizes. So there's three ways to choose the cone size. All right, the next thing we're going to choose is the flavor. We have 15 options. So we have 15 ways to choose the flavor. And our last choice are the toppings. And we have 8 ways we can choose the topping. So we're going to fill this in with an 8. All we have to do is take each way and multiply them together. So we're going to take 3 times 15 times 8, and we're going to get how many total possible ways we could order this ice cream. And if you stick that in your calculator, you should get 360. There are 360 ways that you could choose to order your ice cream. Okay. Second problem. Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? Okay, so let's start off with putting our blank spaces. All right, it's going to have 3 letters and 4 digits. So think about how long that license plate is going to be. 3 letters and 4 digits means it's going to have 7 items on the license plate. So let's go ahead and make 7 spots. If anytime I go too fast, just pause the video. This will work out great for you guys. Okay, so here we go. There's 7 spots on the license plate. So let's start with the first spot. It says it consists of 3 letters. So the first spot is a letter, the second spot is a letter, and the third spot is a letter. So think about how many letters are there in the alphabet. How many can we choose from? Well, there are 26 letters in the alphabet. So there's 26 ways for me to choose the first position. And because the first 3 are letters, I have 26 options in the second space, and I have 26 options in the third space. All right, so 26 ways to choose spot 1, spot 2, and spot 3. All right, then it's followed by 4 digits. So we need to figure out how many digits we have. And this is usually kind of a quick debate in the classroom. So let's think about how many digits we have. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For a total of 10 digits. All right, so we're going to have 10 ways to fill the 4th spot, 10 ways to fill the 5th spot, 10 ways to fill the 6th spot, and 10 ways to fill the 7th spot. And what we're going to do is we're going to go ahead and we are going to multiply all of that together. Go ahead and do that. It'll be a pretty large number. And you're going to find out that you are able to produce 100 375,760,000 different license plates. Okay. Now, at any point, go ahead and pause the video if you want to work ahead and see if you can get question 3 or question 4. I'm going to go ahead and keep going. All right, Nick's science test has a section with 12 true-false answers. Oh my gosh, I got to make 12 spots. Okay, I'm going to have to go kind of small. 1. All right, so he has 12 questions. All right, we're going to go to question number 1. It says that all of them are true-false questions. So if I'm answering a true-false test, how many ways can I answer the question? 2, either true or false. So there's 2 ways to answer the first question, the second question, and etc., all the way down for 12 questions. All right, you're going to take all those values and you're going to multiply them together. So 2 times itself 12 times. As a matter of fact, let's write that. This is 2 to the 12th, which equals 4,096. Okay, one more problem. To enter their home, the Clayton family enters a 4-digit code. How many codes are possible? All right, 4 digits. That means we have 4 spaces. All right, it's a 4-digit code. We already discussed how many digits we have. There's 10 of them. So there's 10 ways to fill each spot. Go ahead, and that is equal to 10 to the 4th. Multiply those together, and you get a total of 10,000 possible codes. All right, this is the fundamental counting principle. Okay, here we go on to something that's called factorial. And this is probably a new word for you in math. And here's what it looks like when they're asking you for a factorial. We're going to put the letter N, and we're going to put what looks like an exclamation point after it. All right, but that is not, we do not say N exclamation point. That is called N factorial. Okay, so what that means is N factorial is the product. Remember, product means multiplication in math. It's the product of all natural numbers from N to 1. Okay, so here we go. An example. Our first question is N factorial. All right, so what that means, our number is 9. That's our N. So I'm going to start with 9. And product means multiply. I'm going to multiply that with all the numbers from 9 all the way down to 1. So it's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we're going to multiply all these numbers together, and that's how much N factorial equals. All right, so grab your calculator. Go ahead and multiply all those numbers together. All right, we should be getting 362,880. Okay, so 9 factorial. I had a friend of mine who also teaches math, and she said this kid had taken a standardized test, whether it was like PSAT or SAT, I'm not sure what it was. But he came back to class and he said, I saw this problem and I don't know what it was asking. She said, well, what did the problem ask you? And she goes, the question was, how much is 5? And I cracked up because he thought it was an explanation point. So anyways, I hope you got a little laugh out of that. All right, so here we go. We're going to do 12 factorial. Now, instead of writing all that out, 12 times 9 times 8 times 7, all the way down to 1, there's actually an easier way to do this. And this is where things can get crazy. We're going to see if this works. If you have your calculator, let me see if I can make this smaller. All right, I should have a Word document down here with the calculator. Okay, if you have your calculator or a different calculator, you're going to look for the factorial button. All right, on the scientific calculator, if you have my calculator, it's above the 3 button. Okay, and I guess, is it going to let me draw? It is right there. All right, so the factorial button is above your 3 button. All right, so here we go. Hold on, I gotta move my computer back so I can write on it. All right, so we're gonna do 12 factorial. So the way that you're gonna do this on your calculator is you're going to put 12 in your calculator, and then you want your factorial button, which is above your 3, so you're gonna hit second, 3, and it's gonna give you your answer. All right, so try it. You should be getting 479,001,600. So 12 factorial is equal to 479,001,600. All right, so try 8 factorial. Now that you know where this button is, hit 8, hit second in your 3 button, and you should end up with 40,320. All right, try the last 2. If you don't have the same scientific calculator that we have in the classroom, there should be a button somewhere on yours that has the factorial. All right, so here we go. We're going to try 17 factorial divided by 11 factorial. So we put 17, second, your 3 button, then hit divide by 11, second factorial, and then you have to remember to hit equals afterwards. All right, so put in 17 factorial divided by 11 factorial equals, and you should get 8,910,720. All right, let's find out what 0 factorial equals. You know that those are always like the little weird ones. So put your 0 in, hit second, hit your factorial, and you'll find out that 0 factorial is equal to 1. Okay, here we go. Oh, let me make this bigger again. This is definitely new to me. Okay, permutations. Permutations is an arrangement or lineup of objects in which order matters. All right, and what a permutation looks like in its little generic form, it's actually right there, but we're going to write it off to the left. It's a little n, it's a big P, and it's a little r. All right, notice how it's a P and it stands for permutation. Okay, we have a formula that allows us to find out how many ways we can arrange items if orders matter. All right, our formula is n factorial over, in parentheses, n minus r, close your parentheses, factorial. All right, n is going to be your number of objects. R is going to be, n is the total number of objects available, and R is the number of objects you're going to use for the arrangement. Okay, and we're going to leave that important shortcut empty for right now. So we're going to jump down to actually question 6. We're going to skip 5 for now. We're going to go down to question 6, and it says, 7 students are competing in a geography B. How many ways can they finish first, second, and third? Okay, if we're in a race, it matters who gets first place, who gets second place, and who gets third place. All right, the order's going to matter. You're going to care whether or not you got first place or you got third place. So what I'm going to do is I'm going to take a highlighter. If you don't have a highlighter, pause the video, go get one. All right, I'm going to take the highlighter. I guess I'll keep it on green. And I'm going to highlight up here where it says order matters. Okay, because you're going to have to decide when you read a problem if the order matters or not. So when I read problem number 6, as soon as I see first, second, and third place, the order is going to matter. It's going to matter whether I get first, I get second, or I get third. Okay, let me go back to my pen. All right, so here we go. 7 students are competing in geography B. How many ways can they finish in first, second, and third place? All right, so our formula is NPR. All right, N stands for, look up here, the total number of objects available. So, how many people are competing in this race? All right, there are 7. Okay, so 7 is going to be our N. And then R, if you look up here, R is the number of objects we're going to use in the arrangement. Well, we're only giving out first, second, and third place. So that means we only have 3 that we're going to fill. So 3 is our R. So there are 7 participants, or 7 objects, 7 people. We're going to give out 3, first, second, and third place. Okay, so let's follow the formula. It's N factorial. N is 7. So it's 7 factorial over N minus R. N is 7. R is 3. It's in parentheses. Factorial. All right. Let's follow order of operations and simplify what's in the parentheses. So we have 7 factorial over 4 factorial. Now, since you know how to do that in your calculator, go ahead and put in 7 factorial divided by 4 factorial. And let's see what you get. You should get an answer of 210. All right, I want to show you a little side note for this over here. If you have 7 factorial over 4 factorial, I'm going to write this out. This means 7 times 6 times 5 times 4, etc., all the way down to 1. Okay, the denominator is 4 factorial. That means 4 times 3 times 2 times 1. Now, if you notice, we have multiplication between all those digits, which means we're allowed to cancel things, right? The 4s would cancel, the 3s, the 2s, and the 1s. So this is actually equal to just 7 times 6 times 5, because from 4 down, they're going to cancel out. So if you do in your calculator 7 times 6 times 5, you'll get 210. So if you didn't have a calculator with a factorial button, all right, this is another way that you could do it. All right, here we go. Oh, wait, I don't know where I'm moving on to. Okay, actually, we're going to do number 5 last. Hopefully I don't forget, so I'm going to put a little note to myself right here that we're going to come back to number 5. Actually, number 5 and 7. Okay, so actually let's go to 8. Go ahead and try this one. There are 16 players on the baseball team. How many ways can the coach make a 9-player batting order? Okay, we're going to take our highlighter again. I want you to highlight the piece of the question that tells you that the order matters. There are 16 players on the baseball team. How many ways can the coach make a 9-player batting order? Right here is where it tells you that order matters. All right, so that means it's a permutation. All right, so we're going to be using our NPR. All right, the N represents how many total players are there? Well, there are 16 players in the team. Okay. How many players are we going to choose for this batting order? 9. So we want to find out how much 16P9 is. All right, so you're going to use your formula, which I will write over here to the left. So it's N factorial over N minus R factorial. All right, go ahead. Pause it if you want. I'm going to keep going. Find out how many different ways we can do our batting order. Okay, so we're going to get 16 factorial over 16 minus 9 factorial, which is equal to 16 factorial over 7 factorial. And I'm going to go ahead and stick that in my calculator, and oh my gosh, we're going to get a very large number of different ways that we could arrange this batting order. Let's see, 4 billion 151,347,200. All right, number 9. I'm going to grab my highlighter because we're going to highlight the part of the problem that tells me that the order matters, the arrangement matters. Okay, there are 28 students in Miss Miller's homeroom. How many ways can the students elect a student council representative and an alternate? Okay, if you're electing people to office, it's going to matter whether you're the council representative or you're the alternate. It's going to matter whether or not you're the president, vice president, treasurer, or secretary. All right, it's going to matter who is what. So the order matters. So we're going to go ahead and write council representative and colleague. Because we're assigning a title, it matters who gets what. Okay, so here we go. So NPR. Okay, N is the total number of students to choose from. There are 28. All right, and where our R is how many are we going to elect? We're going to elect a council representative and an alternate. It means we're only electing 2 positions. So we're only going to choose 2 people. So we want to find out how much 28P2 is. So using our formula, we get 28 factorial over 28 minus 2 factorial, which simplifies into 28 factorial over 26 factorial. Now, I'm going to kind of do this one a different way from before. Instead of just sticking it in my calculator, if I have 28 factorial over 26 factorial, once they get to 26 factorial, they're going to cancel out. So from 26 all the way down to 1, they're going to cancel out. So I actually could just take 28 times 27 and get my answer, which is 756. Now, if you want to double check with your calculator, do 28 factorial divided by 26 factorial, and you should get the same answer. Okay, we've got to go back in and do that important shortcut, which is going to apply to problems 5 and problem 7. Okay, if you have NPN, which just means that your N and your R are the same number, all right, then we have a little shortcut, if you can remember it, that just says it's N factorial. Okay, so on this first problem, we're going to use the formula to show you how the formula turns into the N factorial. Okay, how many ways can you arrange the letter in the word dinosaur? Okay, so we're going to do NPR. Okay, N stands for the number of objects. So count your letters in dinosaur and tell me how many letters we have to choose from. All right, you should have came up with 8. All right, there's 8 letters. And now we're going to pick how many we're going to choose to rearrange. What says that we're going to arrange, how many ways can you arrange the letters? And when they say the letters, they mean all the letters. So I'm going to rearrange all of them, which means I'm going to choose all 8. So there are 8 letters. I'm going to arrange them. I'm going to choose all 8 to rearrange. Okay, if you use the formula, you get 8 factorial over 8 minus 8 factorial, which is 8 factorial over 0 factorial. And we know that 0 factorial is 1. So it actually, you just need to do 8 factorial for the math. So this is how come the shortcut works. If you have a number of items and you're going to choose all the items to rearrange, then you can use the shortcut of n factorial. So go ahead in your calculator, find 8 factorial, use that factorial button that's above your 3, and you should get 40,320. All right, so when your n and your r are the same number, the shortcut is n factorial. Okay, so let's look at number 7. Melanie is taking 4 classes this semester: history, algebra 2, English, and chemistry. How many ways can these 4 classes be arranged on her student schedule? Okay, first I'm going to highlight what told me that the order is going to matter. And the word right here is arranged. Actually, I'm going to do this whole thing. How many ways can these 4 classes be arranged on her schedule? As soon as you see that word arranged, The order matters. So that means it's an NPR. Okay. N is the number of classes that we are have to choose from. Well, there was only 4 listed: history, algebra 2, English, and chemistry. So there are 4 classes. We're going to arrange all 4. All right. When your N and your R are the same number, you can go ahead and use the shortcut, which is 4 factorial. All right, so 4 factorial, stick that in your calculator, or type in 4 times 3 times 2 times 1, and you should get an answer of 24. There are 24 different ways that you can arrange those 4 classes. All right, we're almost done with permutations. All right, here we go, number 10. Now, this is called permutations with repetition. Okay, so we're still going to be arranging something, and order is going to matter. But we're going to have repetitions. What's called repetition? So let's read. Number 10. How many different 10-letter arrangements are possible using the letters in the word automobile? Okay, so here's what we're going to have to do. I need you to count the letters in automobile. Find out how many letters there are. Okay, there are 10 letters in automobile. So we're going to take 10 factorial. Okay, however, there are some repeater letters in automobile that we're going to have to take into consideration. There's a letter that repeats itself. It's the O. All right, so what we're going to have to do is we're going to have to divide out those repeaters. Okay, so we're going to put divide, and I'm going to say O repeats itself. How many times does O repeat itself? Twice. So I'm going to divide by 2 factorial. All right, there are 10 total letters, so it's 10 factorial. Then I'm going to divide out the repeating letters. O repeats itself twice. That's why I chose 2 factorial. All right, put in your calculator, 10 factorial divided by 2 factorial. And you should get 1,814,400. Okay, one more. How many different 9-letter arrangements are possible using the letters in the word disappear? Okay, this one is going to be a little bit different, just because you're going to notice there's more repeaters. Okay, so it already tells us that there's 9 letters in disappear. Okay, so we're lucky here. So it's going to be 9 factorial. Okay, now we're going to have to divide out letters that repeats itself. So let's look and find out who repeats itself. All right, the first thing I see is I see 2 A's. I have an A here, and I have an A here. Okay, so A repeats itself twice. So I have to divide by 2 factorial. Oh, I don't know if pink will be much of a difference. Let's go sky blue. Okay, let's look on there and see what other letter repeats itself. It looks like P repeats itself. P repeats itself how many times? Twice. So I divide by 2 factorial. Okay, so we're going to find out, go ahead and use your calculator, find out how much 9 factorial is divided by 2 factorial divided by 2 factorial. And let me write the answer to make sure that you're putting this in your calculator correctly. All right, you should end up with 90,720. Now, let's say, for instance, that you had a letter that repeated itself 4 times. Like, say we're doing the word Mississippi, and we said, oh my gosh, well, S repeats itself 4 times. Well, then you would also divide by 4 factorial. If you have a letter that repeats itself 3 times, you'll divide by 3 factorial. So every letter that repeats itself, you have to divide the number of times factorial. Hope that made sense. Okay, we are on to the last topic for today, which is combinations. All right, combinations is very similar to a permutation. It's a group of objects in which order doesn't matter. All right, so I'm arranging items, and it does not matter who's first, it does not matter who's last. All right, the order does not matter. So that is the big difference between a permutation, where the order matters, and a combination, when the order doesn't matter. So our combination, off to the left, is going to be NCR. See how it has a C for combination? All right, but N and R still represent the same thing. Okay, N is the total number of objects, and then R is the number of objects we want to arrange. Okay, so this formula looks a little bit different. Okay, so it goes N factorial over N minus R factorial, like you had before. But because the order doesn't matter, there's not going to be as many options. So we are going to have to also divide by R factorial. All right, so it's the same formula. But now that the order doesn't matter, we're going to have less ways that we can do this. So we're also going to divide by another R factorial. All right, and we'll get to that important... actually, you know what? Let's go ahead and fill that in now. The important shortcut, if you're arranging things in the order doesn't matter, and let's say that you have 8 books, and you're going to arrange all 8 of them on a shelf, there's only... I shouldn't use the word arrange. Let me go back. Take that again. Let's say you have 8 books, and you're going to choose 8 books. All right, sorry, arrangement with permutation, not with combination. Say you had 8 books sitting on the floor, and I told you to choose 8 books. It doesn't matter the way that you pick those 8 books. There's only one way to choose those 8 books. So let me say that again. There are 8 books on the floor, all right? So that's your total amount of books is 8. That's your N. And I tell you I want you to choose 8 books. Well, if there's only 8 books, there's only one way to choose 8 books. All right, so that's our shortcut for a combination if N and R are the same. All right, there's only one way to choose them. Okay, here we go. Natalie has 16 close friends. How many ways can she choose 5 to be bridesmaids in her wedding? Okay, so here we go. Order doesn't matter. All right, if you're going to be a bridesmaid, you're just one of 5 bridesmaids. All right, nobody's more special than the other. Okay, we're not getting a maid of honor here. She would be special. Okay, then it would matter if someone who was the maid of honor and one was a bridesmaid. Here we're just choosing bridesmaids. Okay, everybody's going to be a bridesmaid. So it doesn't matter the order that I choose my 5 bridesmaids, which means it's a combination. So we're going to do N, C, R. All right, N is the total number of friends I have to choose from. I have 16 friends. All right, C. And how many of those friends am I going to choose to be bridesmaid? I'm going to choose 5 of them. All right, so we have NCR. All right, let's fill into our formula. So we're going to have to figure out how much. 16 factorial over 16 minus 5 factorial. And we're going to have to do an additional R factorial, so an additional 5 factorial. So let me go ahead, I'm going to simplify this. 16 factorial over 11 factorial, 5 factorial. All right, take a second, plug it into your calculator. Make sure that you can get this answer to come out correctly. So do 16 factorial divided by 11 factorial divided by 5 factorial. And you should get 4,368. Okay, if you're working ahead right now, which I know a lot of you like to do, I want you to stop. There is a reason. Okay, I need you to stop if you're working ahead, and I need you to go back up to number 13. Okay, here we go. There are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to come to his party? Okay, when he chooses 8 to come to his party, the order doesn't matter. It doesn't matter if I choose you first or I choose you 5th. All right, you still get to come to the party. Okay, so here's how it's going to work. We're going to do NCR. There are 24 students total. All right, and then C for combination. And how many am I going to choose to come to my party? It says 8. Okay. All right, I'm going to have to change grab your calculator. All right, I'm going to bring back up my calculator right here. Let me undo what I did. Okay, you actually have an NPR button and an NCR button. All right, if you have my calculator, we're doing combinations right now. I want you to look above the number 8. The heck, why won't it let me draw? Okay, there we go. Right here, it says NCR. All right, we can, instead of using the formula, we can use this calculator button. All right, so if you don't have this calculator, you're going to have to find it. You're looking for NCR. All right, so here we go. Let me flip my computer back over, sorry. Let me make this big again. Okay, so here's what you're going to do to put this in your calculator. All right, we want to put in 24C8. So hit 24, enter 24 in your calculator. The NCR button is above the 8, so hit second 8, then hit the number 8 and hit equals. You should get 735,000. Uh-oh. Let me go back, sorry. 735,471. Okay, I'm going to say that again. If you have my calculator, this is how you put it in. All right, you're going to put 24 on your screen. The NCR button is above the 8, so hit second 8. And then you're going to hit, you want 8 equals. All right, so 24, second NCR, 8 equals. And you should get 735,471. Okay, go ahead and do number 15 and 16. I'm going to keep going. Pause it if you want. And don't close this out yet because we're going to go back and do the NPR button really quick as soon as we do these last few problems to show how that works on the calculator as well. Okay, so 14. Abby's adopting kittens from a pet store. There are 18 kittens, and how many ways can she choose 2? Okay, so I'm going to jump over right here. There are 18 total kittens. I get to bring 2 home. It doesn't matter the order I pick them. They're both coming home with me. So I want to know 18C2. So using your calculator button, I'm going to grab my calculator. I'm going to put in 18, second, NCR, 2 equals, and there are 153 ways that I could choose 2 cats to come home. Okay, 15. There are 12 employees at the sub shop. How many ways can the manager choose 4 for a Sunday evening shift? Okay, so there's a total of 12 employees. I'm going to choose 4 to work. Does not matter the order I choose these 4 to work because they're all working. All right? So order does not matter, which is why it's a combination. So in my calculator, I'm going to put 12, second, NCR, 4 equals, and you should get 495 ways to choose who's working for you that night. All right, last one. There are 85 players in a football team. How many ways can the coach choose 3 to represent the team in a coin toss? All right, they're going to represent the team in a coin toss. It doesn't matter if I choose them first, second, or third. They're going to be out there representing the team. So we're going to have 85 players to choose from, and we want a combination of 3 of them. Okay, so got my calculator. Put 85, second, NCR, 3 equals, and there are a lot of ways to choose this. 98,770 ways to choose 3 people to represent you. All right. This is the beginning of probability. What I want you to do real quick is we're going to go back and we're going to do a permutation. All right, matter of fact, let's go to number 8. Okay, number 8. I'm going to come over here. Number 8, we did 28P2. Okay, so we want to go back to your calculator, and I know most of you have probably already found this already. Let me bring up my calculator. If you look on your calculator, right next to NCR, you should see an NPR. Yeah, see, I'm sorry. I'm going to do this because I got to learn how to do this. I don't know why this is not making me. Okay, there we go. All right. So right here is NPR. Okay, it's above the 9 button. So let's go ahead and come back over here to this. And we're going to put in 28P2 into our calculator. All right, so grab your calculator, put in 28, hit second NPR. Now the NPR is above the 9 on my calculator, and then enter a 2 and hit equals. And you should get our answer of 756. All right, so one last time. Put in 28, second, NPR, 2, and equals, you get your 756. Okay, this is my first shot at online notes. I hope you understood it. If not, if you're listening to this prior to the first day of school, we're going to be having office hours where you're going to be able to call me directly if you have a question, or you'll be able to email me directly, and I'll be able to answer it right there. As of right now, we don't have that set up in stone, but it will be, and I will post it on Focus. Otherwise, you can always send me an email at any time, and I'll answer it as soon as I get it. And I miss you guys, and this is crazy, and hopefully we'll just all get through this together. All right, now I got to go find my thing that's recording. Oh, see, now you guys are seeing all this. I'll bring this back up. I got to stop it. All right, this is a learning curve for me. All right, guys. Oh, remember, fractions are your friends. All right, bye.